Okay, so this is our final video of the 3 that deal with scatter plots. Our first video was simply looking at how to graph and create a scatter plot. Our second video talked about correlation, and this one's going to talk about regression lines. Our objective: write the equation of a scatter plot's regression line and use it to make predictions or approximations. And it's going to tie in a number of things. So let's first get into what we know that's going to come into play here. We know what a scatter plot is. Okay, it's a graph of plotted points, that shows the relationship, if there is one, between two sets of data. Okay, we know the slope-intercept form of the equation of a line is y equals mx plus b, where m is the slope, which is the rise or the fall over the run, and b is the y-intercept, which is the y value when x is equal to 0. And we know what the correlation coefficient is. It's the letter r, represented by the letter r, a number from -1 to 1, that shows the strength and the direction, the strength and the direction of the relationship between two things, between two sets of data. And we learned that when the correlation coefficient r is equal to -1, that's a perfect negative correlation, perfect negative relationship. When r is equal to 0, we have no relationship, no correlation. And when r is equal to 1, we have a perfect positive correlation. Okay, so what's a regression line? Well, a regression line is a line that best fits the data in a scatter plot. So we're going to plot our points, and we're going to come up with that line that best fits that data. Okay, in Desmos, after creating the table of values, we're going to use the equation y sub 1, and then I believe this is called the tilde symbol. I believe that's what that is. So y sub 1 tilde mx sub 1 plus b. So we're using the equation of a line, only we're substituting in this tilde instead of the equal sign, and that's going to give us the line of best fit. And we're going to use this to find the slope, which is m, to find the y-intercept, which is b, and it'll also tell us the correlation coefficient, which is r. And then we can use that line of best fit to answer questions. Okay, let's take a look at the 2 examples we've been working with. All right, of these last 2 to 3 videos. Okay, our first example. Heights versus weights. Okay, we had 6 people. We have each of their heights and their weights. Okay, and we determined that there is I think it was a moderate, maybe, no, it wasn't a very good relationship. It was a low. We determined that it was a low positive relationship. The correlation coefficient being, looking at my notes here, a positive 0.4. So a low positive correlation. Okay, well now we can actually plot a line and answer these questions. Okay, so let's put this data into Desmos and let's put in that y tilde mx plus b and get the answers to these questions here. Okay, so go to Desmos and we'll go to the plus and we'll put a table in and we'll put our data back in because I guess I took it out. And so person A, 64 inches tall with a weight of 165. Person B, 66 with a weight of 160. Person C, 59 inches, a weight of 138 pounds. D, 62 and 120. E, our 5th person, 64, 129, and our last person, person F, our 6th person, 61, 152, and we'll press our magnifying glass with the plus sign, and there's our data. Okay, now let's go to Y2, and we want it to come up with this line of best fit, this regression line. Okay, so we're going to say Y1, and then we want to put the tilde in there. We need to go to the ABC at the bottom down here, and the tilde is right here, bottom row, underneath the B and the end, and there's the tilde. So this is telling us, please find the line of best fit between these X and Y values. We want to put an M is our slope, and then we'll go back to our X sub 1, because we want to use the data from column X sub 1, and then we're going to put in a plus B, and my B is go back to my ABC menu, and there you have it. There is the line of best fit. And it's telling us, we knew this. We did the correlation coefficient in our previous video. This is a slight bit shorter. This only goes out to 4 decimal places, but it's still the same when you round it to the 10th. It's still 0.4. It is positive but low. Okay, it's a low positive. So we have our correlation coefficient. We have our slope, 2.7 if we go to the 10th. And we have our Y-intercept, which turns out to be negative 28. So if we kind of come into here, that data is out there a bit, but I'm going to kind of scroll in. And you can see the line as it goes across the Y-axis, can be a little bit better this way, is crossing here at negative 28. Okay, so our line of best fit for this data is Y is equal to 2.7 to the 10th times X minus 28. Okay, so we'll go back to here, and we'll note that, and we'll begin to answer these questions that we've been asked here. Okay, what is the equation of the regression line? Well, the equation is Y, I'll tell you what, I'll first write down equation of that line of best fit, of that regression line. Okay, again, the regression line is the line that best fits the data. Equation of the regression line is Y is equal to the slope, which is 2.7 to the 10th, times X, and B was negative 28, so plus negative 28 or simply minus 28. There's the equation. What is the correlation coefficient? Well, we were told the correlation coefficient, and we knew this from before, R is equal to a positive 0.4 to the nearest 10th. Okay, what does the slope mean in terms of the data? So our slope is a positive 2.7 over 1. Slope is a fraction. Well, here's 2.7. I wrote it as a fraction. What does it mean? It means, and we've seen this, and we did this in a previous video. We looked at real life slope and how to interpret it. It means there is an increase, because the slope is positive, of 2.7 pounds for each increase in height. Well, let's word that differently. For each 1 inch increase in height. Okay, so remember, slope is rise or fall over run. Okay, there is an increase, it's positive, of 2.7 pounds for each 1 inch increase in height. This is the Y value, this is the X value. Okay, what does the Y-intercept mean in terms of the data? Well, B is equal to negative 28, and we know that this is the point 0, negative 28. Okay, so what this says, 0 is the x-coordinate. Okay, so this says for a person with a height of 0 inches, their weight is negative 28 pounds. That's what it means. The x is 0 inches. The y is pounds, negative 28, negative 20 inches. Now that obviously makes no sense whatsoever. Okay? Normally a line of best fit, the Y-intercept may or may not make much sense, depends upon the data. Obviously, there's no such thing as someone being 0 inches and having a negative 28 pound weight. There's no such thing as weighing negative 28 pounds. But in this case, you know, that's what it is. That's what it means. A 0-inch person weighs negative 28 pounds, but that certainly doesn't make a lot of sense. Okay, and again, the Y-intercept doesn't always or doesn't necessarily make sense when you're doing a line of best fit. Okay, use the regression line equation to predict the weight of someone who is 5 foot 3 inches. Okay, 5 foot 3 inches is equivalent to, let's see, 5 feet is 60 inches. So 63 inches. Okay, so what is the weight? Y is equal to the slope, 2.71, times the height, minus 28. And I need to do this one because I haven't done it yet. So let's see here, 2.71 times 68 minus 28. We would predict, so y is equal to 156.28 pounds. We would predict, using our line, that if somebody 5 foot 3 arrived, 63 inches, a point that's not on our table, we don't have anybody here represented by 63, but we used all this data to come up with a line of best fit, and that can allow us to make a prediction. So we would predict someone who is 5 foot 3 would come in weighing approximately 156 pounds. How do I feel about this prediction? Well, given that R is equal to positive 0.4, which we know is a low correlation. It's not the best. Okay, it's not a great correlation. Okay, how do I feel about it? I think the predicted weight is somewhat accurate. Is somewhat accurate because it's somewhat accurate. We have a low correlation here. Okay, the data is not very strongly related. So, somewhat accurate, okay? It's a nice possibility. Okay, so it's a possibility. But the person could be somewhat lighter or heavier. Okay, I'm not going to say the person's going to be 500 pounds, but you know, it's not a great correlation. It's low on the strength. And so coming in at 6'3", you know, this person might be anywhere from 140 to 170, for example. This is a nice prediction, but I'm not going to think that, oh my gosh, you're going to come in here and be this weight, because I don't have a very strong relationship. Okay, so somewhat accurate. Maybe you could be a little bit heavier, a little lighter. You know, it's not going to be the best because, again, we have a low strength in correlation. Okay, let's now take a look at doing the same thing. I turn my paper over. Okay, let's look at the same thing with this. Remember, we did test scores in a previous video. So let's do the same thing here with those test scores. Now we remember this had a negative correlation that was very strong. It was a high negative correlation, okay? So let's take a look here. We had 10 people, education, number of years education for each, and their score on a prejudice test, where the higher the score, the more prejudice that was that person was determined to have. Okay, what is the equation? What's the correlation coefficient? What is the slope mean? Etc., etc., etc. Similar questions. Let's go back to Desmos and let's put the data in and see what it tells us. Now in this case, I'm going to leave this in here. I'll just change my data in the table. Okay, so I'll just go into the table here and I'll make a change to the data. So I have let's say I have a 12 that corresponds to and this will update as I go. This piece will update. So don't pay attention to this as it changes until I'm done here. Okay, the 12 years was a 1 on the prejudice test, and this obviously is going to flip around too. Just ignore that while we update our table. 5 came out to be 5 years was 7. Okay, we're replacing, and this is all reacting over here. 14 with a score of 2. Fourth person was 13 years of education with a score of 3. Fifth person, 8 with a score of 5. Okay, sixth person was 10 years of education. Whoops, I get the 10 in there. With a score of 4. Now we'll begin to add some rows here. Person 7 was a 16 that corresponded to a 1. Person 8 was an 11, was corresponded to a 2. Person 9 had a 12 years of education that corresponded to a 3. And person 10, 4 years of education corresponding to a 10. Okay, so we can see it held on to the previous X values and Y values. And we can see our data is really kind of stuck in there. So let's go back and press this little magnifying glass with a plus. And there's that data. Okay, and there's that line of best fit. And right down here, it is also updated. We knew the R from before, negative 0.9 to the nearest tenth, a negative relationship that is high, a high negative relationship, a high negative correlation. This is quite strong. It's not perfect, but it's fairly convincing that these things go together. Okay, and the slope of this line is a negative 0.686. We'll call that a negative 0.7 to the 10th. And the Y-intercept is at 11, which we'll round with, 11.0, we'll call it just 11. Okay, so that's what we came up with our line of best fit for this data. Okay, so let's go back to here and let's answer some of these questions here. Okay, the equation of the regression line, we came up with y is equal to the slope to the 10th, negative 0.7 times x, and the y-intercept to the 10th actually turns out to be just 11. The correlation coefficient, r, is a negative 0.9 to the 10th. We said that's a high negative correlation. It's quite strong. What does the slope mean? Well, the slope is equal to, our slope is negative 0.7, negative 0.7 over 1. I'll put the sign with the y values. What does this mean? Okay, that means there is a decrease of 0.7. I don't know the unit. There's a decrease of 0.7 on the test for each increase of 1 year of education. Okay, EDUC. I forgot the A in that word education. That would help if I put that in there. Okay, that's what this tells us. We have a negative slope, so there's a decrease of 0.7. I wrote the slope as a fraction by putting it over 1. There's a decrease of 0.7 something. I don't know what these numbers represent on the test. So for each increase of 1 year of education, the score on the prejudice test goes down by 0.7. Okay, what does the y-intercept mean? Well, b is equal to, our y-intercept is 11. Okay, our y-intercept is 11, which means it's the 0.011. Okay, what this means is 0 years of education results in a score of 11 on the prejudice, P-R-E-J-U-D, on the prejudice test. Okay, there's my y-intercept of 11 as a point. That's 0, 11. The 0 represents the years of education. The 11 represents the score on the test. So someone with 0 years of education has an 11 on the prejudice test. Now, I don't know. If I look at this test, this test may stop at 10. It may be a score from 1 to 10. I don't know. So 11 may not be possible. But that's what that point tells us, whether or not it's true or not. And as we mentioned in the first example, the y-intercept often, because of the line of best fit, often doesn't necessarily make a lot of sense. It may not match the data. It may not make a lot of sense given the data and given the situation. Use the regression line to predict the score for someone with 7 years of education. Okay, y is equal to negative 0.7x. Whoops, I want to have 7 years of education. So I'll put 11 in there, and then not 11, I want to say 7 years of education. Put 7 in for x plus 11, and I'll put that in my calculator because I haven't done that yet. Negative 0.7 times 7 plus 11. This would predict that this person's score would be a 6.1. Okay, a score of 6.1 on the prejudice test. So with 7 years of education, 6.1. How do I feel? I feel pretty good about this because the correlation coefficient is so strong. I feel that this is quite accurate because of the strong or the high correlation coefficient. Okay, again, we found that there is definitely a strong relationship here, a high relationship. So when I use this equation to make a prediction, I can feel good about it. Okay, this is saying me this is really a good strong relationship, and this equation is going to be very valid to make predictions from. Okay, so if they said to me that somebody came in and says, I have 7 years of education, and then you took the test and you came up with a result, I feel pretty good predicting you're probably going to score a 6 on this prejudice test. Or very close to that. Maybe a 5, maybe a 7, but I feel pretty good that it's going to be a 6 based upon this correlation coefficient being so high. Okay, let's look at a couple more possibilities down here. Use the regression line equation to predict the prejudice score of someone with 12 years of education. Okay, let's see here. Y is equal to negative 0.7 times 12 plus 11. Okay, I'll put this in my calculator. Negative 0.7 times 12 plus 11. And this comes out would be with 2.6. Okay, now I put in something with 12, I got a 2.6 score. Now wait a second. If you look up here in the table, I already had a person with 12 here. That person scored a 1. I had another person with 12 years of education. That person scored a 3. Okay, so now I now have 3 scores for someone with 12 years of education. Okay, which one's the most accurate? Well, this score came from one person. Okay, this score came from one person. This score down here took advantage of all those data points to create a line of best fit. And then it used that equation to come up with a score. So we used a bunch of data points here to get this score. Okay, so the most accurate is I'll put most accurate here with a question mark. Most accurate, the one that came from the regression line equation, okay, which is the 2.6. That's going to be the most accurate in general, okay, because it used, why? Because it used all the data. This value came from an equation that used numerous data points. Okay, so that's why it's the most accurate. Okay, we use 10 data points up here. Okay, we use 10 data points up here to create an equation, a line of best fit. And so we say, okay, you know, each of the 10 are different, but when I use this equation, this equation was created using all the data points, including the 2 that had a 12 years of education. It used all of them. So this one's going to be the most accurate because it made use of numerous data points to calculate it. Okay, so there you have it. Quite a bit on scatter plots, regression lines, and correlation coefficients.